Hi everyone, this will serve as a little bit of a demonstration video, just working out a sine graph. We can kind of use the same idea here for sine and cosine. I'll also create a video for cosecant, secant, and tangent and cotangent. They'll be probably linked right underneath this video. So here we have an example where we have a sine function. F of x equals 8 plus 12 sine quantity, pi over 12x minus pi over 6. First thing I need to do is I need to deal with this term here. We are going to factor that pi over 12 out. And what that's going to do, it's going to allow us to more accurately identify the phase shift. Right? We want our phase shift always be in this form, x minus or x plus. Right? Understand that pi over 12 is going to affect the period. So an effect to the period, a horizontal compression or stretch factor, will also affect, our phase shift. So by factoring out this pi over 12, we just make our key features easier to identify so we can more accurately graph our function. So if I factor out pi over 12 from pi over 6, I should be left with negative 2. Right? If I were to multiply that back in, right, if I were to distribute this back, I would get 2 pi over 12 or pi over 6. So I'm going to use that as my first part here. And from there, I'm going to find my other key values. Period always is going to be 2 pi divided by b. In this case, that's pi over 12. So I'm going to simplify that. I get 24 pi over pi. Those pi's cancel, so the period length for this particular function is 24. The amplitude comes from this value here. Let's get a different color. It comes from this value here, so our amplitude will be 12. Even if that 12 were negative, our amplitude is still positive 12. Amplitude is always positive. Our vertical shift, let's keep repeating colors here. Our vertical shift comes from any addition or subtraction outside of the function, right? So this plus 8 you might sometimes see at the end over here, but in this case, they do have it up front. That'll be our vertical shift of 8 in the positive direction. And our phase shift, now that we're fully factored, is going to be 2 to the right. Just because this is a longer process, I'm going to pause the video and set up my axes, and I'll explain exactly how I did that when appropriate. So I've set a few things up here just to kind of talk through my process. My phase shift is going to help me figure out where my trig function, my sine function starts. And in this case, because we're shifted 2 units to the right, that's where we're going to start. If I were to add 24, our period length, to that 2, I get the endpoint, right, of that for that period. So I have a period that's going to start at 2 and end at 26. Because we have this phase shift, it's going to be difficult to work as with 8 blocks here, right? If I had a phase shift of 2 and I made each block worth 3, my phase shift's not going to be on a nice, easy intersection point. So instead, I'm going to use 12 blocks. That should get us where we want to go. So what I'm going to do, I know that I start at 2. Each block is worth 2. So my first block is going to be here. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get the end point of that first period. Well, I did this little extra step down here, so I can just label, right, my starting point and my end point with that information. Now, when we graph these functions, we really want to hit 5 key values where we want to go halfway between the start and the end point of the period. In this case, that'll be at 14. And then we also want to get to the quarter and 3/4 marks. So halfway between 2 and 14 is going to be at 8. And halfway between 14 and 16 will be at 20. So those x values from 2, 8, 14, 16, 20, and 26, those are going to give me my 5 key values for the first period of this function. Let's also think about our vertical component here. We have a vertical shift of 8. I'm going to go vertically by 2. So this is going to be 2, 4, 6, 8. And our amplitude is 12. So we're going to go all the way up to 20. So that's 10, 12, 14, 16, 18, 20. And then all the way down to -4, which will be here. I've seen some students actually go ahead and draw in dotted lines at their maximum and minimum, just to kind of give us some guidelines. And then I've also seen people do the same with the midline. So now we have a lot of information here. But the most advantageous thing we have is our setup here. We are really set up to start graphing. We're going to hit those 5 key points right now. So after all that setup, we've done probably 95% of the heavy lifting here. So what do I have to graph? I have to graph positive sine. Sine, whether it's positive or negative, always starts in at the midline. And in this case, with the phase shift 2 units to the right, we're going to leave that. That's where our sine function is, quotes, beginning. I know that after 24 units, our period length, we get back to where we started. For sine, halfway between min and max, we should also, halfway between start and end of our period, we should have another point on the midline. That's going to be at 14. Because this is a sine graph, at 8, we should be at a maximum of 20. And at 20, we should be at a minimum of -4. We have our 5 important points for our function. And all we have to do is connect those points with a nice smooth curve. Go up through the midpoint, down to the minimum, and then back to where we started. I've only graphed 1 period here, but we certainly could extend this to the right or the left. So that is a sine graph. Stay tuned. You'll see some secant and cosecant graphs as well.